Okay, so get this. Photons, right? Those tiny bits of light.
Yeah.
Scientists are saying they've seen them exiting a material before they entered. Like, what
What?
rewinding reality?
It's definitely one of those, hold on, did I read that right? Moments in science?
Makes you wonder if someone messed with the laws of physics. So we're going deep on this. Two articles, one from Live Science, the other, The Independent, both talking about this experiment. And yeah, it's about time, but not time travel. Not yet, anyway.
Yeah, we got to unpack that whole negative time thing.
Exactly. So for this deep dive, we're separating the science fact from the science fiction-y stuff it makes you think of.
It's easy to get caught up in the headlines, but this experiment, it actually touches on something really fundamental about how time works, at least how we measure it in the quantum world.
Which is always a trip, right? But before we go full quantum weirdness, let's set the scene. We've got researchers, University of Toronto. They're firing photons at a cloud of rubidium atoms.
Super cooled rubidium atoms, to be precise.
Very important. Super cold. What's that doing, making the atoms extra sensitive or something?
Kind of. Imagine these atoms like tiny trampolines.
Okay.
So when a photon, that little packet of light energy, hits the atom, it's like someone jumping on that trampoline.
Giving it a little kick.
Exactly. That kick, that's what we call atomic excitation. Basically, an electron in the atom gets bumped up to a higher energy level. But it can't stay up there forever.
Right. What goes up?
Exactly. It falls back down, releases a new photon, like a little burst of energy going back out. Now, this whole process, from photon in to photon out, takes time.
Makes sense. Even tiny trampolines have their rhythm. So were the scientists just measuring how long this bounce takes?
They were, but that's where things go sideways. They saw two weird things, and I'm not talking about your average, oops, the instrument's off, kind of weird.
Oh, okay. Now you've got my attention. Lay it on me.
First weird thing. Sometimes those rubidium atoms, they got excited even when the photons seemed to completely miss them.
Wait, so like a ghost photon?
Yeah.
Spooky action at a distance.
It's like the photon was passing by, minding its own business, and these atoms were still catching some of that energy. And if that wasn't strange enough...
There was more.
Oh, yeah. Remember how the excited atom spits out a new photon?
Yeah, the whole buoying effect.
Sometimes those atoms were releasing photons way faster than they should have been able to. Like, way faster than the whole excitation and re-emission process should allow.
So they were finishing the bounce before they even start. Okay, I think I need a diagram or something, so that just broke my brain a little.
It's like watching the stopwatch go backward.
Yeah.
The new photon shows up before the old one even hit the atom.
Okay, whoa, hold on. I know where people's minds go with this. We're not actually saying time is running backward.
Right. It's not like rewinding a movie. This is quantum mechanics. Things are a lot weirder and a lot more interesting than that.
Good, good. So what's really going on then, if it's not time travel?
It's all about the photons themselves. See, they're not just these tiny little balls of light. They also act like waves. And like all things quantum, they exist in this weird state of probability.
Okay, so maybe we need to put down our regular clocks and pick up our quantum ones. Listeners, we're going deep down the rabbit hole now. Buckle up. So these photons are like blurry blurs. Instead of a nice clean trip, they're kind of smeared out across time. Is that how we get this negative time effect?
It's more like our usual way of thinking about time kind of breaks down. We like things neat, right? A photon starts here, ends there, we measure the time. But with that wave-like nature, it's not a single point in time, it's a range of possibilities all happening kind of at once.
So not really time travel, but time is so messed up, it looks like the photon went backward.
Our brains really want to put things on a timeline, but the quantum world, it doesn't care much for our timelines. It's like trying to use a calendar to track a dream. Doesn't quite work, does it?
Not unless it's a very weird physics-bending dream.
Yeah.
But, okay, if it's all about how we're measuring things wrong, why is everyone so worked up about this?
Because even if WE get confused, the math, the physics, it's showing something's up. Remember that clock analogy, the rubidium atom being excited for a certain time?
Yeah, our little atomic timer.
It's like that timer is showing negative numbers sometimes. The photon gets emitted before the clock even starts, if we're thinking about it the normal way.
So time itself isn't reversed, but our measurement of it is going haywire. Like, our instruments are freaking out because they're trying to use the wrong rule book.
Precisely. And this isn't just theory, they actually measured this. Not easy, but these researchers, they caught those negative time photons in the act.
Okay, this is where my brain starts to melt a little. Photons messing with time on a tiny scale, I get it. But does this change how the whole universe works? Did someone just rewrite the laws of physics?
Whoa, hold your horses. No universal upheaval just yet. More like we're refining the fine print. This experiment, it makes us look closer at how we measure time, especially when light's involved. Specifically, there's this thing called group delay.
Catchy name.
Right. It basically describes how fast light travels through something, but it accounts for all those tiny interactions happening on the atomic level. Like, how much does the light get slowed down by bumping into stuff?
So not just the speed of light we learned about, but how that speed gets tweaked by all this quantum shenanigans.
And this experiment, it makes us rethink group delay itself. We thought it was always a delay, light hitting the brakes a little. But now, it seems maybe, just maybe, that delay can be, well, negative sometimes.
Hold up. So not only are photons acting bizarre, they're making us rethink how we measure really basic things. The universe is messing with us, isn't it?
In the best way possible. It's a reminder that there's always more to uncover. We're peeking behind the curtain, and it's wilder than we imagined.
Makes you want to check your physics textbook out the window, doesn't it? Start fresh.
No, maybe hold on to it for now. But yeah, it's humbling and exciting. We clearly still have a lot to learn, even about the fundamentals.
Listeners, if you're feeling a little mind blown right now, that's okay. You're in good company. It's a lot to process. But hey, that's what we're here for, right?
Yeah.
To explore these mind-bending concepts together.
Absolutely. And even if these ideas seem abstract, they really matter. They change how we understand the universe and our place in it.
So where do we go from here? If something as basic as time can get fuzzy, what other impossibilities are out there just waiting for us to find them?
Right?
Like, if time can be kind of bendy, what else have we gotten wrong?
Exactly. It really makes you think, what other weirdness is the universe hiding? And how do we even begin to wrap our heads around it?
Big questions. And this experiment, it's not giving us all the answers, is it? If anything, it's like more doors just opened.
Absolutely. But that's the beauty of science, right? It's not about having a complete map. It's about exploring, getting comfortable with the unknown.
So for our listeners who've been on this brain-bending journey with us, what's the one thing you hope they take away from all this?
Maybe next time they check their watch or set an alarm, take a second to think about those photons. The way they're playing with time at a level we can't even see. Our universe is a lot stranger and a lot more amazing than we usually give it credit for.
Well said. I think I need a little break from mind-blowing physics, personally. Maybe a nice fantasy novel where magic has rules,
I hear you, but then again, isn't it that sense of wonder that keeps us coming back for more? Makes all the head-scratching worth it.
You've got a point. Well, on that note, we'll leave everyone to ponder the mysteries of negative time and the quantum realm. Thanks for joining us for this deep dive. We'll catch you next time.